Hello, my name is Kyle and today I will be showing you how to handle, redirect, discard and count packets using Honey Potion, a project that harnesses the power of eBPF with the ease of writing elixir code. If that interests you, let's get started. First, let's see how we can drop and redirect packets. To demonstrate this in live action, I have set up 4 terminals. The top 2 are clients that can send messages and the bottom 2 are servers that receive messages. As you can see, the top left is connected to the bottom left and the top right is connected to the bottom right. In this case, the left 2 are on port 3000 and the right 2 on port 3001. Before I show you the program, I'd like to show first its effect. Let's run the drop UDP program provided with Honey Potion and try sending a message from the 3000 port client. Nothing arrives. How about the one in port 3001? You can see that its packets are being received by the server in port 3000. That is because the eBPF program in the Linux kernel is dropping the packets that are destined to port 3000 and is redirecting those in port 3001 to 3000. Of course, this feature can be very useful for debugging, load balancing and even more. Now that I've shown you what the drop UDP program does, let's see how it's done. Here on screen, you can see the code for the drop UDP. Unlike past videos, I would not be teaching you how to write the 2 programs in this video, so if learning how to write Honey Potion programs interests you, please visit the playlist in the description after you're done. However, I will be starting now a small description of this program. We start with the name of the elixir module for our program. Then we inform elixir that we wish to use Honey Potion and the license of our program. This line allows Honey Potion to take over the compilation of the main function. And also, before the main function, we must define what sort of trigger will call our program. In this case, we'd like to have our packets as our trigger, so we define it as xdpmd. Finally, we can start with the main function. To use the Honey Ethernet header library, we must first call init. This library allows us to observe and interact with packets. With it, we want to check if our packet is of the type UDP, and if it's in port 3000 or 3001, as those are the ports that we are interested in. This is done with the if statement for UDP and this condition for the port 3000 or 3001. In the case of port 3000, we call xdp drop, which drops the packets, not allowing it to go to the rest of the operating system. This also stops the program from running, so we don't go on after this point. In the case of port 3001, we modify the destination port to become 3000, so that when it gets to the operating system, it reaches the correct port. Finally, we need to call xdp pass for the packets that we wish to go onto the system. This includes the modified 3001 packets and the other packets that aren't affected by our system. These values can be changed to affect other ports too. Another useful program that we can make using Honey Potion is traffic counter. In this case, we will be counting how many packets we get from each MAC address that reaches our computer. More specifically, this will be triggered by a single network interface. In the case of Honey Potion, we target the localhost network by standard. So when running it, you'll notice that we keep track of only one MAC address, our own. We can go ahead and change this network interface to the one with internet and see the results. To create the traffic count example that can log packets that enter your computer, we have a program that starts similarly to the drop UDP up to the part where we initialize the Ethernet header library. From here, we can get the number of times this MAC address has shown up before, add the number of past occurrences by 1, and update the value like so. For our values to persist in memory and be visible to us, we have to use an eBPF map. This can be done with the def map macro that is specified above. Here we can see that we are creating a hash-like map because we wish MAC addresses to be our keys, which allows up to 64 entries, prints out the results, and has a key size of char6, which is to match the way that we keep and print out MAC addresses. So, today you have learned how to use Honey Potion to handle network packets. In future updates to Honey Potion, we are planning on adding support for more functions into our Ethernet header library, like handling TCP packets, changing more parts of the header, more advanced filtering of packets, and even more. I hope you have enjoyed this video, and until next time.